My name is Austin Stone, and today I will be showing you how to use the deviceWISE Atlas Copco driver. Some prerequisites for this tutorial are that you must have deviceWISE installed, you must have the deviceWISE workbench installed, you must have a license for deviceWISE, and you must have the Atlas Copco driver package. The first step is to install the Atlas Copco package. Once you have installed the Atlas Copco package and your node has restarted, you are now ready to create your Atlas Copco device connection. The next step is to add your Atlas Copco device. Head on over to the Devices panel, select New, name your device. I'm going to name my device Atlas Copco, and then select the proper type from the type dropdown. Under Atlas Copco, I am going to select Power Focus. Enter your IP address. Enter the port if it is different than the default. Change your revision level if it's different. Single spindle or multi-spindle. In this case, I am a single spindle. I'm going to leave the keep alive time at 6 seconds because that is sufficient for my device. And the timeout I'm going to leave at the default 5000. If you select Use Advanced Properties, there are other options, mostly related to subscriptions. First, we have VIN. You can subscribe to the change of the VIN or change of identifiers. You can also subscribe to PSET or choose not to. You can subscribe to jobs or not. You can subscribe to alarms. You can receive missed tightening messages. You can enable diagnostics, which is used for general diagnostics of the tool. This is not actually part of the protocol. You can subscribe to trace curves, mid-900 messages, and per variable security is an advanced property for all device-wise actions. We can go ahead and save and select Start. If everything was successful, your device should now be in the started state. Once your device has been started, head on over to the Variables panel, either by selecting Variables from the tabs up top or by dropping down the Devices tab and selecting Variables. You will see a structure called Atlas Copco, which contains all of the Atlas Copco variables. If you click the plus, it will expand this structure. Inside, we have lots of different data associated with Atlas Copco. Cell ID, channel ID, controller name, last message received, active VIN, the active parameter set, active jobs, and some identifiers for different parts. If we decided to come back over to the Devices panel and selected to subscribe to missed tightenings, diagnostics, trace curve subscription, and we hit save, it will ask you to restart your device. We'll select yes. The device should start, and if you head back over to the Variables panel, you'll see that we have a new structure called Diagnostics. Under here, we have things like if the subscriptions are on or off, the last tightenings that you've received, error messages, other types of messages that are non-rundown related, and then the total amount of messages you've received for things like tightenings, alarms, trace messages, etc., and the last heartbeat time. These are variables that can be read on demand. Now that I've shown you how to connect your Atlas Copco device and I've shown you the Variables panel, let's head over to Projects. And let's create a new project called Atlas Copco. Select OK and click Start. Once your project has started, you can navigate into the project by double-clicking it or by dropping down the Projects tab and selecting the started project. Projects are where we create business logic using triggers. Let's create our first trigger by clicking the New button. A window should pop up called the Canvas Editor. In the Canvas Editor, we can add action blocks to create business logic. First, let's make a name for our trigger. Then we can select the trigger event type. In this case, we are going to do on demand. In the Canvas Editor, you have lots of tools and logical operations available for you. For example, an if statement, a for loop, end execution with success, end execution with failure. Below, in this left panel, you will see lots of different structures, and these are groups for action blocks. Action blocks are like functions. They take some input and give you some or many outputs. If we open up the Atlas Copco group, we will see that there are many actions available to us. For example, we can abort a job, we can enable or disable a tool, get tool data, do batch increments and decrements, we can reset the batch counter, we can select a specific job on the Atlas tool, select a parameter to be set on a specific tool, we can change the batch size, we can set the VIN number on a tool, set and reset digital input values, and we can subscribe to a tool. In this example, let's select a specific parameter on the tool. Click on the select parameter set and drag it onto the canvas. A connection should automatically be made between the start and the action block. This is the logical order in which things will be executed. Because all we're going to be doing in this example is selecting the parameter set, we can immediately end execution. You can do that by coming up to the top left, selecting the end execution block, dragging it onto the Canvas Editor, and connecting it to the action block. Exit. Now let's open the select parameter set action block. Inside, you will see we have different input types, static or dynamic, and the name of the device which you wish to set the parameter on. Because we don't want to dynamically feed in the device name, we are going to just use a static device name, and we're going to use the device that we created called Atlas Copco. Down below in the input table, you will see the pset ID, which is a logical type of uint2. We can map this to any variable in deviceWISE to have this dynamically change, but in this case, we are going to hard code this value as 2. Now you can exit the action block. You can click the validate button to validate that your trigger was created successfully. And now you can click the save button. Select close editor. Now you've created a trigger. Let's go ahead and click the start button to get our trigger started. Because our trigger is on demand, we must demand it to execute. We can do this by right-clicking on the trigger and selecting Fire Trigger. If you go down to the refresh button and click that, you should see that there have been 1 successes. Now that our trigger has executed successfully, let's go back to the variables panel and check that the pset has changed. Drop down the Atlas Copco device, open up the active parameter set structure, and double click on parameter set ID to read the ID. You should see that the parameter set ID is now 2. In this case, I had to demand the trigger to execute to set the parameter set ID to some constant. You can also do different types of events to execute triggers. For example, let's create a new trigger. Let's name it trace data. And under the trigger event type, if we look under Atlas Copco, you'll notice that we have something called Atlas Copco event message. If you select this, we again have a device name selection. We are going to use the device that we created called Atlas Copco. And under event message, you can fire this trigger based on many different types of events. For example, the last tightening result, a mid-61. You could also do a multi-spindle result for multi-spindle tools, a mid-35 for job information, a mid-65 for old tightening results, or a mid-900 for trace results. In this case, we're interested in trace results. We don't have a database set up yet, but let's look at some of the event variables. Drag the set action block onto the screen, and under source, you can click the drop down and look at event variables. You will notice we have things associated with event like IP address, number of points, point timestamps, points. These are the different points associated with the mid-900 message which was received. The result data identifier and the tightening ID are both identifiers for the rundown. The timestamp, that is the first timestamp of the mid-900 message. Trace type tells us if it is angle, torque, current, etc. And unit is the unit of the trace type, such as Newton meters or angle, degrees. Now let's look at a mid-61 event message. Select mid-61 from the event message dropdown. Go back to the set action block. Open up the dropdown under source, and you will notice that there are many different event variables associated with the mid-61 message. Now, whenever a rundown happens on your Atlas Copco tool, you will get a trigger firing with all of those event variables. You could send that data somewhere. You could perform some sort of operation on the data. You could have a display show the data in some way. You could really perform just about anything. Alright, so now that we've looked at how to set up your Atlas Copco device and how it can be used in trigger logic, let's go ahead and look at an actual application. First, if we head down to the devices panel, you will see that I have a power focus device already started. And if I go over to the projects panel, I have a project called Atlas Trace Demo that contains a few triggers. The first trigger, rundown, is to capture rundowns, mid-61 messages. It simply inserts them into a database and writes to a device to signal that the database insert has completed. I also have a trace one that does the exact same thing, but for trace results. You can see that it's building up arrays and then doing a batch insert into a database, and again writing to a global device to say that the database insert has completed successfully. The reason these array fills were necessary is because some of the returned values are single values, and we needed them in an array format to insert them with the array data that's returned. And last but not least, we have the set pset, which allows us to change the pset on the tool. I mentioned that we used a global device to signify that the database inserts were successful. That is the device right here called Atlas PF TID. And in here, if we look at the variables, it has a pset, a rundown tightening ID, and a trace tightening ID. Whenever we get a new rundown or a new trace event, these values will be updated, and since our web application that we're going to create subscribes to these tightening IDs, it will know when the database insert has happened, and so it can go and fetch the information from the database. And let's go look at the databases real quick. In our databases we have two. We have one for the rundowns and one for the trace messages. In the rundowns, there's simply one row for every rundown. In the trace, there are actually 1,000 rows per rundown, and they all have the same tightening ID, those 1,000 rundowns. So let me summarize real quick what we've done here. This is also that our web application can use the data coming from the Atlas Copco tool. First, we have our Atlas Copco device. We've connected it and started it. Then we created 3 triggers. One of the triggers was for mid-61 rundown. So every time there is a rundown, we insert all that data into a database. We have the exact same thing for trace data, but the database insert is slightly different. Once these triggers have finished inserting into their associated databases, they write to a global device to signal that the insert has completed. The third trigger, the set pset trigger, is there to simply set psets. Now we can go on and look at the application. First, make sure that you have the WebSockets API or the JavaScript Web API installed on your deviceWISE node so that you can query deviceWISE for that data. Head on down to the administration panel and make sure that your HTTP server is started. In this case, my address is localhost 88, but by default it is port 8080. So if the HTTP server was not already running, you'd come down here and hit Start Server. And now we need to write our code for our web application. If you head on over to the staging browser, you will see there's a folder called www. Inside this folder, we have the web API under the deviceWISE folder, and then you can have your own web applications in here, and you can format this however you'd like. You can also get to this staging directory by going to your File Explorer, C directory, deviceWISE, runtime, staging. And again, you see the www folder, and here's where you will place all of your files for your web application. Today I'm going to be showing you guys the Atlas Trace demo web application. So let's go ahead and open up our web browser. You'll want to navigate to the URL that was on the HTTP server panel in deviceWISE. In my case, it was localhost 88, and the path is Atlas Trace Demo, that's the folder, and then the file is index.html. When you pull up this web page, so this web application is showing us our last tightening result data and our torque and angle trace data. In the top you'll see we have a status for the last rundown. We have the current pset, the current VIN, which is empty in my case. We don't have a VIN set right now. You have the torque value for the last rundown, the angle, and the batch count and the batch total. Below you'll see the status for the torque for the last rundown, status for the angle, and the number of batches out of the total that have been completed. Below you'll see your 3 graphs for angle, torque, and torque over angle. We can also click this menu here on the top right, and it will show us different view options. So maybe we only want to see angle, or maybe we only want to see angle over torque, or we could choose all. We can also decide which device we want to send to, or which device we want to receive data from. the number of traces that you want to see on the graphs, and this we could say we want to see 5, and it would overlay 5 of the most recent tightenings over the graph. You can look up specific tightening IDs. So for example, we could look up tightening ID 605 or 4 and click lookup, and it will change our graph and show us the last 5 from 604 and back. If we click the reset button here, we should go back to the most up-to-date tightening ID, and under pset you can change the pset. So now let's make this full screen, and we'll go ahead and do a rundown. So as you can see, our status is good for each of our rundowns. You can see the angle and the torque curves, and if we'd like to, we could look at, maybe the last 3 rundowns, and they're all very comparable, no outliers. Our batch count is behaving properly, and this is all being fed from deviceWISE. So some of these variables are subscribed to directly, such as pset. Whenever the pset changes, we display the pset. Other things are pulled from the database using SQL queries. So for example, torque, angle, and batch count. Whenever a certain variable changes that we've been subscribed to, the rundown tightening ID, then we know to go query our database and display our new values on our web page. Similar concept with torque and angle. Whenever the trace tightening ID changes on our global variable device, we know to go do an SQL query on our database. We look for all of the traces that match a certain tightening ID, and then we parse the trace type and put it into the corresponding graph using, in the back end using JavaScript. So I hope you guys enjoyed this demonstration of deviceWISE and the Atlas Copco driver.